Welcome to day 26 of the System Design Process and Best Practices course. In today's session, we will be focusing on designing for performance. We will cover key aspects such as latency, throughput, response time, caching strategies, and content delivery networks (CDNs). In this session, we will discuss the core concepts of performance design. These include latency, throughput, response time, caching strategies, and the role of content delivery networks or CDNs in improving system performance. Let's begin with three essential metrics: latency, throughput, and response time. Latency refers to the time it takes for data to travel between the client and server. Throughput measures the number of requests processed per second. Response time is the total time from when a request is initiated to when the response is received. To reduce latency, there are several strategies we can adopt. Firstly, we can use content delivery networks (CDNs) to cache data closer to the user's location. Minimizing database queries and reducing the number of hops between services are also key strategies. Additionally, optimizing code and identifying slow operations can significantly reduce latency. Throughput can be improved by employing techniques like load balancing, which distributes traffic across multiple servers to avoid overwhelming any single one. Parallel processing allows us to handle multiple requests simultaneously. Lastly, using queuing systems like RabbitMQ and Kafka for asynchronous processing helps in better handling of large volumes of traffic. To reduce response time, database optimizations like indexing and query optimization are crucial. Server-side caching helps avoid redundant computations, and asynchronous processing can minimize blocking operations. These techniques help make the system faster and more efficient. Caching is a powerful technique to improve performance. We can implement client-side caching where data is stored locally, server-side caching where data is cached at the server, and distributed caching where tools like Redis or Memcached. It also important to choose a cache eviction strategy such as recent least recently used LRU, first in first out FIFO, or least frequently used LFU. Cache invalidation is another key concept. We need to ensure that cache data remains up to date. This can be achieved through mechanisms like time to live (TTL), write through, and write back strategies. These techniques help us manage data freshness and optimize cache efficiency. Content delivery networks or CDNs are networks of servers distributed across multiple locations. They cache content closer to the user's geographical location, significantly improving access speed. CDNs help in reducing the load on the origin server and provide a more reliable content delivery experience. CDNs improve performance by reducing latency, serving content from servers located near the user's location. They also enable better load balancing by distributing traffic across multiple servers and provide faster access to static contents like images, videos, and documents. Performance testing and monitoring are critical to ensure the system meets performance goals. Load testing simulates high traffic to test how the system handles the load, while stress testing evaluates its breaking point. Tools like New Relic, Prometheus, and Grafana can help monitor system performance in real time and provide insights for improvement. There are several performance metrics we need to track, including response time, which measures how quickly requests are processed. Throughput indicates the number of requests handled per second, while error rate shows the percentage of requests that result in errors. Monitoring resource utilization such as CPU, memory, and bandwidth usage is also important to maintain system efficiency. In conclusion, to design for performance, we must focus on reducing latency, improving throughput, and optimizing response times. Implementing effective caching strategies and leveraging content delivery networks are essential for boosting system performance. Continuous monitoring and testing will ensure that the system remains optimized and scalable. Thank you for your attention. If you have any questions or need further clarification on any topic, feel free to ask.